Vaporizers. So basically the vaporizers are classified as far as what is the method of regulation of the flow. Method of regulation of the flow of the vapor from the vaporizer. Method of regulation of. So the method of regulation of flow can be of main two types: variable bypass method or the measured flow. Variable bypass and measured flow. In the variable bypass, you can have variable bypass with concentration calibration. So majority of the tech vaporizers are variable bypass and concentration calibrated. They are not measured flow. So method of regulation of the outlet concentration or output concentration. That is the first thing you always test. So all these tech vaporizers, they have variable bypass with concentration calibrated. You can have a concentration calibrated. What do you mean by concentration calibration? Means if I select 1%, it will give 1%. That is a concentration calibration. So the other thing is method of the vaporization. How the vaporization occurs inside. Whether it is the flow over or bubble. Flow over or bubble. Draw over is entirely different type of vaporizer. They are the EMO vaporizer is a draw over. Otherwise, major classification of vaporizers are draw over and bubble through. Sorry, draw over and plenum. Plenum and draw over. Plenum means you are forcing gases with a positive pressure. That is called as plenum. All our present day vaporizers are plenum. We don't have any draw over. In olden days, we used to use a draw over vaporizer, that was an EMO. And if you go to some places like in Pune, the vacancy, they have a EMO. EMO vaporizer will be there, a solid steel this thing, roundish, okay, and if it is there, you have to say that is EMO, Epstein Macintosh Oxford vaporizer. So Epstein and Macintosh, so they were the pioneers in designing this in Oxford. Oxford is also not a name of an anaesthesia. Epstein and Macintosh in Oxford. So sometimes they may ask you about EMO, but commonly this thing. And EMO has got an outside water jacket is there. Outside water jacket, EMO. And you have to first fill the EMO vaporizer. The water jacket has to be filled. So they'll ask you how do you fill the EMO water jacket. So how do you fill, anybody?
From the bottom.
Yeah, there is a bottom, there is a opening is there. You have to invert the EMO vaporizer. They open the lid of that the water jacket and then pour hot water, close it and then keep it back. So this is one thing is very important. Many of the places they have old colleges, if you go, they may have these EMO vaporizers and fantastic vaporizers. It itself is a machine. It itself is a machine. So wherein you can carry anywhere in the field. Also, it was actually made for World War, Second World War. EMO vaporizer was designed. So you also combine with Oxford bellows, combine with the bellows, Oxford bellows, and you can even go for muscle relaxation, and then you can manage the controlled ventilation also. So that is the importance of EMO vaporizers with Oxford bellows. So EMO, now we'll just come to the classification of these vaporizers. This is a draw over vaporizer. All other vaporizers, what we have is plenum vaporizer, where the gases flow with the pressure. Gases, we don't have any, even a Goldman vaporizer is also a plenum vaporizer, because all the gases will come with the pressure, isn't it? Maybe lower pressure, but they are not negative pressure. The draw over vaporizer, the patient creates a negative pressure because the gases are drawn because of the negative pressure. That's why they are called as draw over vaporizers. These are all plenum vaporizers. So first thing I said, that method of regulation of output concentration, either variable bypass with concentration calibration or measured flow. The copper kettle was a measured flow vaporizer. Just remember about the example, copper kettle, measured. Second classification is method of vaporization, whether flow over or draw, not draw, flow over, only flow over or flow over with bubble. Only flow over, that means the gases flow over the surface of the inhalation anesthetic agent, it picks up the vapor, or they are being made to bubble through the vaporizer, and then once they are made to bubble through, the surface area of the bubbles is much higher, the concentration, output concentration will increase. That's how some of these vaporizers can be made to be bubble tube. For example, if you have we have inside. So a Boyle's bottle is both a flow over and a bubble tube. A Boyle's bottle is both a flow over and a bubble tube. Okay, the third thing is now whether the temperature compensation is there or not. And if it is there, what is the method of temperature compensation? So temperature compensation, if it is there, it can be by two things. One is by supplied heat. Just now I talked to you regarding EMO. EMO is a supplied heat also, and also it has got the other thing is there, alteration of the flows. The other thing is alteration. There are two methods by which the temperature compensation can occur. One is you are supplying the heat whatever is lost. That is the supplied heat. Second thing is you are altering the flows. That means if the temperature is dropping inside, you are pushing in more and more gases to pick up more molecules of the vapor, and so the concentration is outlet concentration is maintained. That is called as the altering the flows. All these will have an alteration of the flows because the metallic strip is there, bimetallic strip. So with the different specific heats, so they will change there. It becomes bent whenever there is decrease in temperature, so that more amount of flow can occur through the vaporizing chamber, less amount of flow can occur because through the bypass chamber. Usually you'll have two chambers, bypass chamber and vaporizing chamber. So the next classification is whether you can use this inside the circuit or outside the circuit. Whenever we say inside the circuit or outside the circuit means it is always a closed circuit. Don't think that inside the circuit or outside the circuit is for open circuits. It is not for open circuits, it's mainly for closed circuits. So suppose, can I use it within the closed circuit? That becomes the vaporizer inside the circuit. If I use it on the machine like this and then it is nowhere within the circuit, then it is called as outside circuit. All plenum vaporizers can only be used outside the circuit. So no plenum vaporizer can be used inside the circuit because their resistance is very high. And that resistance, who has to manage? If the patient is on spontaneous, patient has to manage. So that's how we don't keep any vaporizers inside the circuit. Sometimes they do ask which vaporizers can be kept inside the circuit. In olden days, only Goldman's was kept inside because the amount of the resistance it offers is much less when compared to all other plenum vaporizers. Only Goldman's vaporizer. You have seen Goldman's vaporizer? Not seen. You have inside. We'll bring it and then show after some time. Okay. Still, a lot of time is there. No problem. So that is the another method of knowing the how to classify. So now you have how many this thing? Yeah. What are these? What is there? No, method of vaporization. Okay, then whether you can use inside the circuit or outside the circuit. And then agent specific. One more thing, that's what I was thinking. Which one I have forgotten? Agent specific. Now halogen is there, vaporizer is there. Can I use any other volatile application? Isoflurane can still be used, but you should not use it. Why isoflurane can still be used? Pressure. Pressures are 240, roughly in that range. Because majority of these vaporizers are constructed based on the vapor pressure to the ratio to the atmospheric pressure. So that's why 240 is the vapor pressure of both halogen and isoflurane. But you said that it can be used. Why we don't use? Suppose I pour inside halogen, I have poured isoflurane. Okay, still I can use isoflurane because the concentration, outlet concentration will not change because the vapor pressures are same. If I am giving 1% isoflurane, if I keep the isoflurane inside, instead of isoflurane I pour halogen, then I keep it to 1%, it will give only 1%. Halogen also it gives 1%, isoflurane also it will give 1%. Now why we don't use? We have a separate MAC is different. MAC varies, but the thing is you should know what it is there. Suppose I don't know that, I think that it is isoflurane and what I am giving is halogen. Halogen is more powerful. That's what I said MAC. MAC is the one which gives the potency. And highly potent halogen, it is 0.75 5 is the Mach and 1.25 is the Mach of 1.2 is the Mach of isofluid. That's the reason. Though you can use isofluid, this is another common question they'll ask you. So why don't we use? Because you know the vapor pressures are same. Why don't we use? So you can't use because the potency varies, the Mach varies. Okay. Now that's why agent specificity is very important. Now for example, if you have a boils bottle, so they can be used for any vapor. Whether you can use for trilene, you can use for halothane, you can also use for ether. Many times you can say that they are not agent specific. So all these tech vaporizers are agent specific. So suppose if I want to classify this, it's a variable bypass, flow over, temperature compensated by altering the flows, agent specific outside the circuit. Fine. So we'll not discuss too much about these vaporizers. We'll go next to the other things. Only thing that they'll ask you majority of times is how do you classify vaporizers. Sometimes EMO can be there, so you have to know it's the draw-over vaporizer. In EMO, the two methods of temperature compensation is there. One method is I told you they just supply heat because of the outside water jacket. Inside the vaporizing chamber, there is a metallic bellows. A metallic bellows is there inside the vaporizing chamber, which will alter the flows. Suppose if there is increased temperature, the bellows will expand. As the bellows expands, the amount of air going into the vaporizing chamber comes down. Whenever the vaporization starts and then the vaporizing chamber temperature comes down, then the bellows will constrict. So more amount of air will enter into the vaporizing chamber, picks up small bellows. The small bellows, not the Oxford bellows where you use outside. It's a small metal bellows which will be there inside at the inlet of the vaporizing chamber. Okay, that is two advantages. You want to go? Okay, all the best. Do well. Happy journey. Their buses are there at 8:30. So 7:30. Now metal bellows, you see, for example, let us say this is the chamber. At the inlet of the chamber, inlet and outlet both will be the same. So inlet you have a metal bellows. So if the temperature inside the vaporizing chamber is more, the bellows will expand. So the amount of air entering, because the patient is drawing air, the amount of air entering will come down. So once it starts vaporizing and the patient is using this vapor, the temperature inside the vaporizing chamber falls. So then the bellows will constrict. So more air will enter and pick up. So outlet concentration is normal. So their concentration calibrated. EMO vaporizer, it is again a variable draw over, but variable bypass, draw over variable bypass, concentration calibrated, and outside the circuit agent specific. So these things you have to keep on telling somebody and then you have to rehearse. So because why I am so fluent about all these is because so many times, so many students, so many batches, I keep talking about these things. So naturally that fluency will come. So for you also, keep telling somebody, if you meet your friend, ask about, okay, come on, how do you classify vaporizers? So let him talk. Or hey, just stand here, I just want to tell you about classification of vaporizers. Keep telling. So that's how you can always, the expression is very important. How you express there in front. So suddenly, what happens every time, you will be knowing, you will not know how to express things there. So that's why keep on talking, or even if nobody is there, you stand in front of a mirror and keep on talking there. So as if the mirror is the examiner and you are answering. Okay. So that's what is very important, because many times I have seen the student will be knowing, so it becomes very difficult for us to extract